Hi everyone, good afternoon. And today we are going to talk about the source pollution attack, a hidden threat in cybersecurity.
The green button is for the next.
Oh, okay, thank you. Let's see. Okay, so here is the outline for today's talk. So first, we're gonna define what the source is for you, and later we will explore the relationship between the source and the CTI. Later, we are gonna get into our main topic, which is source pollution, and we will propose some case studies for you to understand how a source could compromise your CTI and affect the company's security posture to the outside. Following that, we will propose some methods to help you to mitigate this kind of issue. And finally, we will conclude our talk with a summary of some key points. So hi again, my name is Boik, and I am currently working for Cycraft Technology in Taiwan as a senior security researcher. And also, I am one of the members of Change Roots, which is a local hacker group in Taiwan, who helps organize the annual HITCON events. I do not know any of you have heard of HITCON before, but it's a local security conference located in Taiwan. So I suggest if you have time, you can drop by the conference. And my primary areas of expertise can encompass web security, AD security, and threat hunting. Over the years, I've given talks at various conferences, such as HITCON, OWASP Global AppSec, HITB SecConf, and HackerOne.
So, hello everyone, my name is Stanley. I'm a cybersecurity researcher at Cycraft Technology, and I'm specializing in automated malware analysis and threat hunting and web security. I've given talks at Cybersec and HITCON Enterprise in Taiwan.
Okay, so before we start our main talk, I would like to introduce you a typical infrastructure of a company, how it looks like. So we can observe a common pattern that where firewalls are placed, positioned at the forefront in order to protect or defend common obvious attack attempts. And IPS and IPS systems ladder will help you to defend or prevent malicious incoming traffic. However, as the internet evolves, we need some additional concept or methods to help us to protect further against adversarial attacks. So we need some new concept or tools to help us in this way. So for instance, we have NG firewall here, next generation firewall. So next generation firewall is an advanced firewall that can help you to infer the layer 7 protocols for you to know actually what services are running. And with this information, we can further identify if the connection is benign or malign by consuming various sources. Such sources such as the signatures or the geo-IP database, or even the indicators of compromise. So from a simplified view of how an NG firewall works when there is incoming traffic, we know some sort of sources are there that can help us to detect if the connection is malign or benign by inspecting the traffic, the content of the packets, and then we can match these patterns to our well-known patterns to see if the contents has some malicious content that can harm our business, or even to break our applications. And likewise, we have another component here, which is secure email gateway. So SEG inspects email using signature analysis and the machine learning techniques to block the malicious email or like the phishing attempts, spams, or emails with malicious attachments. So SEG acts in almost the same way by consuming some sources and makes the decision afterward. Blacklist malware signatures plays pivotal roles here. So here is also a simplified view of the processing flow of a secure email gateway. So almost make the same conclusion, just like we saw the previous case, the NG firewall. And let's look at another example here, secure web gateway. So SWG provides some functionalities to help you to filter unsafe content or to apply some application controls. So these capabilities also come from the help of various sources that come in handy, such as blacklist, malware signatures, or like traffic patterns that we can extract from some open source IPS database patterns. So by utilizing various sources that contribute from various aspects of a single web traffic, so secure web gateway gains insights into the nature of the traffic and its potential impact on the underlying web applications. Okay, so right now you have the basic sense of how sources could help you to protect your company's assets, and you know how sources influence the products that you use every day. So what exactly is a source, that you might ask? Well, a source is a piece of information that is either transmitted in the public. You can retrieve this kind of information from the public, like the data from the articles, from the forums, etc. And we also have another types of information that will be transmitted privately, secretly among people in the clique. Since we are discussing source in the security manner, they are more akin to factors contributing to a specific event. Actually, U.S. Department of Defense has a formal definition of sources that are used to form the OSINT. So you can say that the DoD said sources are collected, exploited, and disseminated in a timely manner to an appropriate audience for the purpose of addressing specific intelligence of requirements. These sources are contributing to the OSINTs that we know, and we have been used by security communities for years. And many types of source out there supporting OSINTs. So we have like news, we have social medias, public information like the open data from the government. We have reports and articles. We have talks and seminars like we are here in the FirstCom. And we have mass population data that we can retrieve from like OpenStreetMap or Wigo. And we do also have some free format text that you will have to later analyze by yourself, by person itself, and more. And actually, there is a framework called OSINT framework that has covered almost all things that you can come up with, and even things that you have no idea about in the past. So if you do not know this framework, I suggest you check this framework later. And typically, OSINT can be used in many ways, so such as composing alerts or news for subscribe readers. And also, there's another usage like the OSINTs can provide you supplement information that can correlate with other sources to provide additional information regarding your assets, regarding the vulnerabilities that you are looking for, or even more. Nowadays, many new concepts also leverage OSINTs to help analysts to make their jobs easier. So for example, the security orchestration and automation and the response, which is SOAR, platforms have connectors to integrate various OSINT sources into one platform. And LLM models are trained with OSINT data, something like that. Okay, so then I will let Stanley to talk you about what's relationship between source and the CTI.
Okay, so now we understand the definition of source. You might be wondering, what does source have to do with the CTI? So let's have a quick review of the different types of CTI. The cyber threat intelligence and offers information and insights into threat actions. It can help people to create more reliable detection rules and mitigate attacks. Since building CTI requires expertise in multiple professional domains, enterprises typically rely on the proprietary CTI solutions provided by others rather than building their own CTIs. All these proprietary CTIs are considered sources, and moreover, the tools that you use to collect or analyze the CTIs are also considered sources because they can have different means to the interpretation. Okay, so take IP domain and blacklist as an example. These types of CTI can help block the low reputation or malicious sites. They are commonly used by firewalls, email service, and ISPs to mitigate the insecure connections. Following the definition and relationship between sources and CTI, the providers who maintain their blacklists are considered sources. For example, the DNSBL, Spanhouse, and Abuse IPDB. And there are many other ones that have created their own blacklist. The figure on the right shows which organizations that have blacklisted the requested IP address as a malicious one. The network fingerprints have similar effects to the blacklist. They are used to identify malicious websites. Several fingerprinting techniques have been developed in the past few years, including the JAR3S, DRUM, and JAR4+. Using the same concept, the sources are parties that maintain fingerprints. As the figure on the right illustrates, the SSLBL has collected a large number of the JAR-string hash, and they can use it for the detection. One of the network fingerprint, that is the JAR4+, is designed to replace the JAR3 because it can provide a wider range of protocols beyond just the TLS. And JAR4+ includes lots of other protocols such as the HTTP client fingerprint that can analyze each HTTP request. And the light distance locality can measure the distance by examining the latency between the first few packets sent between the two clients. And the next one, the X509 TLS certificate fingerprinting, can be used to identify how the certificate is generated. And this SSH traffic fingerprinting will analyze the SSH sessions. And there are lots more in the JAR4+, and it is still developing. Okay. The signature-based CTI can apply not only to the network traffic, but also to the files, specifically the malware signatures. And antivirus and sandbox tools utilize this signature for the prompt detection results. These signatures can be utilized in form of raw information, such as the file hashes, or you can integrate them into rows, like the Jaeger rules or the Sigma rules. All the authors who create and publish the rules are considered sources in our case. And next one is common and easy to use CTI. DNS records contain much more information about the domain than most people realize. For the service disclosure, many services require domain owners to set up the verification code in their TXT records for authentication. The verification codes often contain information about the service. For example, the Google site verification also denotes that they are using a Google service. The SPF record restricts who can send emails from this domain, and thereby enhancing the email security to mitigate spoofing. And in this case, we can see that the Google's SPF record is designated to send emails on their behalf. The CAA record specifies which certificate authorities are allowed to issue certificates containing their domain names. If there is no CAA records, all CAs are allowed to issue these certificates. In this case, only Google Trust services are permitted. These types of CTI can be retrieved either via active DNS requests with DNS resolvers or via the passive DNS data. Okay. So now we understand how CTI sources can benefit the cybersecurity community. And let's now take a look at how sources will negatively affect the security posture. So before providing concrete examples of how polluted sources might affect your company, we want to briefly illustrate the potential threats when dealing with sources. Attackers may utilize various tricky ways to pollute the information, such as forging the signatures or creating rogue DNS resolvers to respond with the incorrect DNS records. Or they can trick the middleware into falsely handling the original source data, or hijacking well-known social media accounts to disseminate fake news. These tactics may further be amplified during the CTI stage, because we need to combine CTI stages from different sources to get more context about an incident. And by combining these tactics, the attackers can eventually result in the 3 cases we will talk about today. And there are also lots more that is not mentioned in today's talk. So the first one will be the information confusion. And it will also cause denial of service or unwanted downloads. Okay, so the first negative effect is the information confusion cases. Okay. As mentioned before, the JOM is a network fingerprinting hash. This JOM hash represents the TLS server configuration, and therefore having same JOM for 2 different TLS servers is possible, and such occurrences are not uncommon. When such a situation occurs, scanners that rely on comparing JOM hashes cannot differentiate between the normal servers and the malicious one. This issue has various consequences. On the one hand, if the malicious server can conceal themselves as the legitimate one, then they can make communication to the victims. And on the other case, if the legitimate server is falsely detected as the malicious one, it will get the reputation low and may not be communicated by others and cannot serve their service. The multiple blogs and news have pointed out the issue of forged drum signatures. The first case demonstrates how to spoof the drum signature to appear as a Global Strike server. And this also implies that a malicious server can potentially spoof as a benign one. The next case illustrates that the engineering team behind Drum also acknowledged the occurrences of Drum hash collisions between the Global Strike server and the burp collaborator. In this scenario, we are going to examine how tools used for handling sources can impact the results. GetDNS is an open source project that makes efforts to provide a synchronous DNS API. The figure depicts a web GUI that people can test with to get the DNS response quickly. GetDNS supports multiple DNS resource record type and with the DNSSEC related information. While it makes DNS information easily accessible, the JSON responses are not well formatted. As you can see, if we save the JSON result into a file, and we use the JQ command to try to read this JSON file, it causes the parsing error. And we discover that the issue is caused by the value of NSEC, a DNSSEC-related resource record type that is used for proof of non-existent. The present value is started with the \0, and this is not the valid format of JSON. And well, it turns out that this is not just a one-off case, because the backlines is a mechanism used by Cloudflare to help save CPU cycles when responding with NSEC. It works because the NSEC record is much smaller than the original one. As their block states, they always return \000 as the next name for a non-existent domain. Our next negative effect discusses the denial of service. DShield is a free and open service that provides a platform for users of firewalls to share intrusion information. Their primary goal in collecting data is for network security research. By analyzing this information, they are able to provide blacklists that summarize the top 20 attacking class C subnets over the past 3 days. They also provide other IP lists, which are little filtered and should not be used as blacklists. For example, the top 100 source IPs and the all source IPs are mainly used for security research only. People might neglect the warnings and continue to use them as blacklists. Those who mistakenly use the incorrect list may block legitimate IP addresses, resulting in their inability to access services from those websites. The figure below shows the content of the top 1,000 list, which explicitly declares that do not use it as a blacklist. In addition to using those incorrect lists directly, one may try to use the list provided by the third-party collections. However, as the figures illustrate, these collections are not always reliable and may contain incorrect information. For instance, the firewall IP list still maintain a copy of the deprecated IP list from the digital top 1000 list. So next, I'll let Borg to continue the last one.
Okay, so last we want to talk about the unwanted downloads part of the outcome that were resulted from the source pollution. So if a source can fool you into download anything that you are not allowed or you are not really noticing about it, that is a catastrophic event, right? So we are going to talk about the real case one. So the real case here is the NPM registry inconsistency. So here we can see that NPM is a JavaScript package registry for users of Node.js community will be using this registry to download and manage their packages for their projects. However, the NPM public registry doesn't validate if the package's metadata is really identical to the one that's specified in the table. So that could lead to people or the products that use this information to believe that the package is exactly as it declares. So this bug was reported by the former engineering manager of the NPM client team. So we can show you the code here, and it is still on the NPM registry. So as you can see here, the package.json here said that there is a dependency called sleepover right on the screen. However, as you look up a little bit on your upper right, you can say that the NPM tells you that there's no dependencies there. So once you download this package will actually install this package for you and execute it anyway. And it behaves the same on the Google's open source insight service, which is dapps.dev. As you can see that this information also comes from the sites that we mentioned, the NPM registry. So there is also zero dependencies here, shown on the open source insights website. According to the reporter's blog post, Sockets was the only one at the moment that could actually identify this issue, and it flags it as manifest confusion. And indeed, it checks both positions to make sure that the file, the string declared by the metadata.json is really identical to the one it has in the table in the file. So consider this: if we trust the source, download the package, and execute it, malicious file will be executed on our end, and that is typically the RCE. Okay, so eventually in our final topic, we want to bring up some ideas and suggestions for you to mitigate this kind of issue. And there are mainly 2 points. So the first one is multi-factor validations. And the first is what we want to make sure that you have actually validated the source that you are using in your daily task, and even to put the validation process into your CTI lifecycle. And make sure to pay attention to any changes of the source, and always have a backup plan if any source that you are using suddenly shut down or being taken over by malicious actors. Automation is getting attention nowadays because CTI analysts start feeling stressed when they are dealing with any kinds of events, and they will have to look for any information out of a bunch of sources. So we can see that LLM has helped analysts to make things better and easier, but don't forget that the LLM model has its own problem, which is LLM hallucination. And the second and the final point is to always make sure that what source you are using or relying on mostly. So one day if there's any security incident happened, you will be freaking out and you will better enact the recovery plan if any incidents happened in your company, and you know that which sources are in charge of that. For instance, Penthouse, a trusted authority on IP and domain reputation data, one day mistakenly blacklisted the email server's address of some major companies, such as Outlook or like Gmail, and resulting in a widespread denial of service on their users. If people don't know the source they are relying on, a company could be heavily affected, resulting in business loss possibly. Okay, so here comes to the conclusion of our today's talk. So in today's talk, we want to emphasize that the importance of validation, validating the source that you rely on every day, and to understand which source you rely on can help you better enact a recovery plan. If in some scenarios they play a significant role in your workflow to ensure the overall security hygiene of your company. And finally, don't take high reputation sources for granted, because there will be some unexpected events happen that you don't know, as mentioned in the previous slides. So better prepare yourself for any takedown or like the abrupt stop. Yeah, anyway, you just to prepare yourself for something like that. And basically, that's the end of our talk, and thank you for listening.